Hello students. Today we're going to talk about solving systems of equations by graphing. Now we mentioned systems of equations yesterday when we did the pretzels and the marshmallow activity, but we didn't get into a whole lot of details. A system of equations, as it says here, are two or more linear equations in the same variables. And in our case it'll be x and y. Now, the solution of a system of equations is an ordered pair that satisfies each equation in the system. It is imperative that you understand what the solution is. A solution is one ordered pair that satisfies each equation in the system. Now let's look at our examples from yesterday when we talked about the heads and legs problem. So I'm going to look first here and look at number 1. At Homestead Heritage Farm, I counted horses and ducks in a fenced area. In all, there were 18 heads and 46 legs. How many horses were in the fenced area? So we solved those problems yesterday looking at pretzels and marshmallows, but how can we set them up as an equation? Well, because we're dealing with heads and legs, one of our examples is going to be an equation about heads, and the other one is going to be an equation about legs. Okay? So we've got horses and ducks. I'm going to call horses x because it's first, and the ducks are going to be y. And I know that there are 18 heads in all. So my first equation is going to be x plus y equals 18, because the number of horses plus the number of ducks is going to be 18 heads. Now when we talk about legs, we've got to figure out how many legs does each of those animals have. Well, a horse has 4 legs, so that's 4x. And a duck has 2 legs, so that's 2y equals 46, because that's the total number of legs that it says that the farmer saw. Now when we looked at the equations yesterday and we figured these out, we figured out that my solution was 5, 13, because there are 5 horses and 13 ducks at the farm. Now, what does that mean? That means that if 5 is x and 13 is y, is 5 plus 13 18? Why, yes, it actually is. And is 4 times 5 20 and 2 times 3 26? Is 20 plus 26 46? Yes. So the solution is 5, 13, because that's the ordered pair that satisfies both of the equations in our system. So our next example that we're going to look at is the second problem. At Cameron Park, some cats were chasing some birds. I counted 25 heads and 84 legs when I watched the cats and the birds. How many cats were chasing birds in Cameron Park? So now I have to decide again which animal is going to be x and which is y, and I'm just going to go in order. Cats would be x and birds would be y. And I know you don't have this paper with you right now. That's okay. As long as you're writing it on the notes page that you have, that's fine. So we know there are 25 heads, so I know that x plus y is going to equal 25. Now let's talk about legs. Cats have 4 legs, so that's going to be 4x. Birds have 2 legs, that's going to be 2y, and it equals 84 because that's the total number of legs. Now when we solved this problem, we know that there were 17 cats and 8 birds. So let's plug that in and see. 17 plus 8 is 25, so it satisfies the first problem. Now 17 times 4, that's 64, plus 2 times 8 is 16, no, that's not 64, it's 68. 17 times 2 is 34, plus 34 is 68. So that'd be 68 plus 16. Is 68 plus 16 84? Yes, it is. So 17, 8 satisfies both equations, so it is the solution to the system of equations. And then you see this hint down here that says, check to verify if the ordered pair is a solution to the system of equations. So here I'm given an ordered pair, and I have to see if it actually is a solution to 2 equations that they give me. So let's plug it in. 4 plus 2 is 6, so it works for the first equation. What about the second? 4 times 2 is 12. 12 plus 1 is not 11, it's actually 13, so the answer to this is no. And if we look at the second one, we've got 4, 3, and we've got 2 equations. Let's plug it in to see. 4 times negative 3 is negative 12, and 3 times 2 is 6. Is negative 12 plus 6 negative 18? No, it's not. So we already know that no, that is not a solution to a system of equations. Before I pause, what I'd like to do is look at the brain stretcher. What can happen to two lines on the same coordinate plane? I'm not going to give you those answers right now, but what I'd like for you to do is write down what you think. If I have two lines on the same coordinate plane, what are some things that might happen to with those two lines? Hopefully you've had a chance to write down a couple of things on that question, what can happen to two lines on the same coordinate plane? And so now we're going to talk about how do you find the solution to a system of equations if you don't have any pretzels and marshmallows at your house. That would be a fun way to do every one of them, but we don't have that opportunity. So there are actually 4 different ways that we can find the solution to a system of equations, and we're going to learn those 4 ways as we go through the next several days. We're going to start with graphing the functions, the linear functions, to see what the solution is. And then we're going to do substitution method. And then after that, we're going to do an elimination method. And then after that, we're going to use multiplication before we can eliminate. So those will become more clear as we go through the next weeks. But we're going to look at graphing first to see how we can find the solution to a system of equations by graphing. So here's something to note. One way to solve a system of equations is to graph the equations on the same coordinate plane. The solution to the system is the point where the lines intersect. Okay? Just like we talked about earlier, the solution to a system of equation is the point that satisfies both equations in the system. Well, if they cross, then that means that they're a point on both lines, so it's the one point that satisfies both equations in the system. Now let's talk about some special cases. If the lines are parallel, are they ever going to cross? No, so there is no solution because they never cross. Now if the lines coincide, there's a new word, coincide, which means they have the same slope and the same y-intercept. That means basically they're exactly the same line. So it's one line just right on top of itself, maybe in a different form. Then there are infinitely many solutions because they cross at every point because they're exactly the same line. Okay? Just some special cases. We'll talk more about those a little bit later. So we're going to look at example number 1. Example number 1 gives us 2 equations in our system, y equals x minus 4 and y equals negative 4x plus 1. So let's graph both of them, and I'm going to use 2 different colors to graph them, and a ruler. A ruler is imperative for these problems. If you don't draw a straight line, you're never going to find the correct solution. So let's start with y equals x minus 4. I'll do it in red. Okay, I know that my y-intercept is negative 4, and I know that my slope is 1, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, and I'm going to draw my line. And just like I always do, arrows on each end. Okay, and now let's use green for the second line, y equals negative 4x plus 1. Well, I know my y-intercept is 1. And I know my slope is negative 4, which means I go down 4, 2, 3, 4, into the right 1. And then I go down 4, 1, 2, 3, 4, into the right 1. Yeah, I didn't go down right, so I messed that up. Down 4 to the right 1, it should be right there. And then down 4, 1, 2, 3, 4 to the right 1, we should be right there. I apologize about that. And now, where did those 2 lines cross? Those 2 lines crossed at that point right there. And that point is 1, comma, negative 3. So my solution is 1, comma, negative 3. Now let's check to make sure. What is 1 minus 4? Negative 3. So that worked. And if I plug in 1, negative 4 plus 1 is negative 3, it worked for that one as well. So let's hop over here to example number 2. The first equation is given to me in slope-intercept form, y equals mx plus b. The second one is not. So the first thing I need to do, and I'm going to use green, is to rearrange this so that it's in y equals mx plus b form. And I need to subtract 2x from both sides. So it's going to be y equals negative 2x plus 2. I subtracted 2, and the 2 is 2x, and the 2 is still positive, so y is negative 2x plus 2. While I have green, we might as well go ahead and graph that one. So I know my y-intercept is positive 2, my slope is negative 2. I go down 2 over 1, down 2 over 1, down 2 over 1, and I'll draw my line. And now I'll use red, and the red line is negative 2x minus 1, so I know that my y-intercept is negative 1, my slope is negative 2, or negative 2 over 1, so I go down 2 and to the right 1, down 2 and to the right 1, down 2 and to the right 1. Oh, wait. The slopes are the same. So what does that mean? It means the lines are parallel. So what's the solution? There's no solution, because those lines never cross. And so let's look at our last one. Example number 3. X minus y equals 5, and 3x plus y equals 3. So let's graph this one together. First of all, I need to manipulate x minus y equals 5, and that's going to be, since y is negative, I'm going to move y to the other side. So it's going to be y equals x minus 5. So basically the y and the 5 switch place. And then on this, let's go ahead and graph it. So my y-intercept is negative 5, and my slope is positive 1. So there's my line. And then now I'm going to subtract 3x from both sides, and so we get y equals negative 3x plus 3. So I know that my y-intercept is positive 3, my slope is negative 3 over 1, which means I go down 3 to the right 1. I think I did that one correctly. Down 3 to the right 1. There's my intersection. Down 3, 1, 2, 3 to the right 1. Right there. Okay, draw my line. That's where they intersect. Sometimes it's really nice when they intersect right there on one little point, and then you can find it quickly. And so the solution is 2, 1, negative 3. So let's plug it in and see. Is 2 minus negative 3 5? Absolutely. What about 6 plus negative 3? 6 plus negative 3 are the same as 6 minus 3, and that's 3. So yes, 2, negative 3 is the solution to this system of equations. I know you missed me, so I decided to make a little quick appearance. The practice problems are on the back of your notes page. There are 2 that you're going to graph. So graph those 2, take a picture, and submit it via Edmodo. If Edmodo's acting crazy, then just email the picture to me and have that in by class time on Friday so we can work with them when we get to class.